another to replace the expired server. This is our usage, some of our usage models. The benefits of line migration at AliCloud is that we can, first, by line migration, we can consolidate the VMs to server and improve the VM density. By improve the VM density, we can earn more money. And the other benefits is that we can do cloud maintenance. This maintenance is transparent to customers. And this is some of the benefits. But in AliCloud, line migration is not an easy feature because we have some problems. For example, first we have hundreds of guest OS types, and some of the guest OS types are not friendly to line migration. For example, they have PVZI problems or QEMU problems. So some of the guest OS are not friendly to line migration. The second problem is that we have different kinds of server. The CPU types are a lot the same. When we migrate one VM from one server to another, if the CPU processor types are not the same, it will block line migration because line migration have a TSC problem. This problem has not been solved by Zen and Kevin right now. Maybe in the future, in the recent future, we have solutions for these problems. But now, migrate from one CPU to another kind of CPU, a lot allowed. And AliCloud has 5 or 6 years. Some old history block line migration. For example, at old ages, we use static VNC port binding to the VM. So if we line migrate one VM from one server to another, if the VNC port was occupied by another VM, that will be a problem. And another difficulty is that we have diverse storage types and the network types. So this different network and storage types will bring problems for line migration. This is the environment. Cloud environment is very complicated, especially for AliCloud. You know that AliCloud is a big cloud with hundreds of thousands of VMs. So the environment is very complicated. We use Zen 4.0.1. This is an old Zen. And at that time, Zen is not friendly to line migration. For example, its QEMU has a lot of problems. And the PV drivers has a lot of problems. And the hypervisor, we cannot update online. So if hypervisor have problems, we cannot hotfix it. And at that time, line migration was controlled by ZenD, written by Python. Python performance is not good, and at that time, XL is not mature enough. So these are all the problems we meet. And for line migration at AliCloud, we need high performance and high reliability. We must ensure that 100% VM will not die during the line migration. You know that some line migration will fail because different kind of various reasons. For example, the memory pressure or other reasons, we cannot successfully migrate one VM. But we must ensure that the VM will not die. Okay, this is the issues and the challenges we meet at AliCloud. Our work focuses on line migration, optimization, and enhancement. There are two targets. One target is high performance. Another target is high reliability. We use the open source Zen 4.0.1. At that time, we test the performance, and the performance is very, very, very bad. And the downtime is 3 seconds to nearly 20 seconds. This is unacceptable at the AliCloud real environment. So we have to optimize the performance. This figure is the original open source Zen line migration. From this figure, basically it's a serial procedure. This is the source side, and this is the target side, and they do the line migration step by step. And at the source side, they will suspend the VM at one point. This point is a time 1. And after they suspend the VM, they will do the last iteration memory copy, and send the VM context, and send the QEMU context, and then destroy the VM, destroy the device. At this point, they will close the socket. Okay, this time is time 2. And after the socket close, the destination side will do the rest work. For example, they will complete the restore, and then unpost the VM. At this time point to this time point is the downtime. After unpost the VM continue to work. But at this time, the network doesn't work. So we need to connect the backend driver and the front-end driver VF. Then we will do some, for example, send grad RP to route the network. This is time 2. This time to this time is the break time. The downtime is that means that the time CPU didn't work, and the break time is that the time network didn't work. This is the open source Zen the Zen migration. This time is very big, 3 seconds to nearly 20 seconds, and this time is bigger. For example, 5 seconds to 30 seconds. And if the downtime if the break time and the downtime is this time, the network will break, and the customer, the VM, when we migrate one VM from one server to another server, the network will not work. For example, the TCP will disconnect. So we have to optimize it. The basic idea of optimized line migration consists of several fields. One field is that we use a new event driver parallel line migration. The old Zen line migration is serial, but now we change it to parallel line migration. We use an event drive mechanism based on Zen store. And this event drive mechanism can separate the virtualization, network, and storage. So each component can work independently and parallelly. And the second point is that virtualization optimization. Virtualization optimization, we do some work. First work is that we bypass the domain destroy. You know that when we destroy a domain, we need to free all the memory. But for Zen has a big problem is that the memory scrap problem, because when Zen free a memory, it will clear all the pages to 0 and get the Zen heap lock. Zen heap lock is a big lock, so so the time is very time consuming. Oracle several months ago at Zen Hackathon, Oracle provided solution for memory scrap issue. In fact, they provide two solutions. One solution is that to change the big Zen heap lock to NUMA lock. Another solution is something like solution 1, but at that time, these two solutions are not agreed by Zen community. Are not totally agreed by Zen community. So this is a problem. At AliCloud, we bypass this point. We use another way. And virtualization optimization, the second point, we use a new shorthand for cumulative transfer. The reason I will tell you at the next figure. And we do some work for storage optimization and the network optimization. You know that in real cloud environment, there are different types of storage and different types of network types. For storage, for example, the community usually use type disk 2. For type disk 2, we have to, sorry. And this is the figure AliCloud used. That means we optimized the line migration procedure. Point 1 is that at old Zen, the destroy VM will consume very long time. For example, 2 seconds or 2 seconds to, for example, 20 seconds, because we need to free memory here. But at that time, this is the send cumulative to the destination. But problem is that at the destination side, they don't know how much data should transfer. So they receive the data. They receive the data context at this point, but it don't know it has finished. So they wait until the domain was destroyed and the socket closed at this point. So they always wait at here. This is a very long time. In our current AliCloud, we changed this point. At this point, we calculate how many data need to transfer and send the length to the target. For example, currently we use 6300 bits, and the source told the destination. That's the length. So when the destination received enough data, they definitely know that I have received all the cumulative data, so they can continue. Don't need to wait this work. This is point 1. This is optimization point 1. Point 2 is that we don't use the heavyweight destroy device here. Instead, we use the lightweight type disk pulse at here. That means we don't need to wait it destroy the type disk device. Instead, at very early time, we do a very lightweight work at here. That means we use type control pulse to flush all the dirty data to the disk. And after the storage do the lightweight work, at the destination side, we can do the storage reopen. It's also a lightweight work at this point. From destination side, I have just introduced that our line migration is parallel work. So it's based on event mechanism. At this point, there are 3 parallel work. The storage is a thread. Storage is a thread, and the virtualization is a thread, and the network is a thread. At this point, the ZenD will trigger our event, told all the other components that it is okay for us to do the destination side work, the trigger event. After the storage, we design a storage daemon to monitor the event. After the storage gets the event, the storage daemons, now that the storage should reopen its type disk at this point. Similarly, the network at this point received the event. So the network will do the send grace RP to send RP, and all this work are parallels. These are C thread, and these are C thread, and these are Python thread. The Python thread only do the virtualization work, and the storage and the network are parallel, propel their own work. After all these 3 components finish their work, they join at this point. And at this point, the VM can unpost safely. Unpost safely, that CPU can work, that network is propelled, and the storage is propelled. So they happily go on. This time is very short. And in fact, after this point, the VM work very good at the destination side. This is our optimization for the downtime and break time. I have some data to show our optimization result. And this blue column is the data of Zen 4.0.1. The time increase with the VM memory size increase. One is for example, 512 megabit. The time is 2.5 seconds, and when the memory increased to 16 gigabyte, the time is 17 seconds. They increase, and the yellow date is the Zen server time. The Zen server time is about 4.5 to 5 seconds. The downtime is some bigger. Is some good, better than open source Zen, but it's still very bad. And in AliCloud, we optimized it to about 200 milliseconds. So compared with Zen server, we improved about 20 times. And compared with open source then, we improved about 10 to 70 times. And the break time, this is break time. For Zen, it's 3 seconds to 25 seconds. For Zen server, it's about 8 or 9 seconds. But at the AliCloud, we only have 500 to 300 milliseconds. The result is good, I think. And under this date at AliCloud, the customer didn't all the line migration is totally transparent to customer. We do the line migration at AliCloud. The customer feedback that they really don't know we have do the line migration because the time is short enough. At the reliability enhancement, we have do some work, and this work is now still continue. First, we do the redundant storage and the network design. You know that line migration have some risk, but in the field of storage and the network, we both do the redundant work. That means if, for example, if we fail at this point, network didn't work at this point for any reason, for example, some wrong software version or any other reason, they didn't work at the network demo didn't work at this point. That's not problem. We have a control system. After this point, the control system will send another centigrade RP. So we have do two actions to ensure that network will work after we transfer to destination. For storage, we have also two works. If it didn't work at this point, that's not a problem, because the type disk didn't connect to the VM at this point at the destination. But after this point, the VM will send I/O to our storage system, and at our storage system, with Alibaba design the distributed storage system for ourselves. If it didn't work at this point, after this point, the first write I/O we will reconnect to the Alibaba storage system and reopen at this point. So the storage and the network are reliability enough. And for reliability, we have another enhancement. You know that line migration is a virtualization feature, but in real cloud environment, we didn't solely rely on the virtualization level. We design a closed-loop line migration. That means the virtualization level will feedback and send all the status, all the events and the progress to AliCloud controller. AliCloud Cloud controller is a central controller per pool. So if we line migrate from one server to another server, both the source side and the destination side will feedback the progress and the events to the controller. And the controller will receive all the events and the progress. In the cloud environment, sometimes the source or destination site will fail because of different kind of reasons. For example, in our real cloud environment, we once meet a problem. We use a ZenD version at the source site, but use a wrong ZenD version at the destination site. So the destination site didn't work. So the controller received the status and progress from source side, but didn't receive the status and progress from destination side. So under this case, the controller will judge what's the problem and make the decision to kill which VM. So based on the closed loop line migration, the reliability improved obviously. But currently, we still didn't ensure 100% VM survive. This work will be done very in 1 or 2 months. I think we will achieve this target. And this is some example of we use line migration at AliCloud. Case 1 is that we purchase many servers, but some servers have fancy malfunctions, and the server cannot work normally. About 200 servers was impacted. We use line migration to migrate all the VMs of these servers to the pool and to back up the server and change the fence and then migrate back. These work are totally transparent to customer. And at that time, the VM survival ratio is 98%. The only reason is that we installed wrong ZenD installation at 2 physical servers. So at that time, we didn't get the 100% of VM server. This is case 1. Case 2 is that memory and the disk I/O failure is often happened at the cloud. If the memory failure is UCNA type or SREO type, we can safely migrate the VMs from one server to another. But if this memory failure is SRER, we're not sure that the VM can be migrated. I mean, the VM impacted by the SRER error. But if the VM was not impacted by the SRER error, it still can be migrated. And another case is that server consolidation. We consolidate about 150 servers to 20 servers and save the servers for new business. And at this case, 100% VM survive. This is our current status, but for the future work, we have 2 issues need to solve. One issue is, that under big memory pressure, the break time and the downtime will increase because the dirty page of last round has many dirty pages. So the time will be very long. For example, 3 seconds or 5 seconds at this level. So to solve these problems, we should use the post-copy technology. For post-copy, we need to cooperate with Zen developer at community. The second problem currently we meet is that the TSC issue. You know that the RD TSC the performance will drop badly if we migrate to different CPU types, because after we migrate, we use the simulated way we use the emulated way to emulate the TSC. So the performance will drop badly. For these issues, we have cooperated with Intel, and Intel will provide a new Broadwell at the Broadwell EP server. They will add some microcode to the VT about RTTSC scaling, and then at that time, we can solve these issues, TSC issues. The reason why we need this, why we need to solve TSC issue is that we need to support a heterogeneous NAND migration. Heterogeneous NAND migration is highly desired at the cloud computing, because some old server expired. We need to migrate to new servers. The CPU types are different, so we really need this feature. And now we are cooperating with Intel Corporation to solve this problem. And this is the recent feature work about AliCloud NAND migration. And this is our current status. And any questions?
How much of the optimization that you did here is present in newer extended versions?
Sorry?
How much? So you did some optimizations here, right?
Yes.
So for example, for the migration speed.
Uh-huh.
And you did that on 401, on Xen 401. Is some of the optimization already present in newer Xen versions like 4.6?
No, because we use old version.
But are some of the problems solved in newer versions?
I think some of the problems are solved, but I'm not sure. For example, these problems are not solved because at the 4 months ago, when I met Conrad at the Linux hackathon, at that time, Conrad was trying to solve the memory scrub issue, but he provided 2 solutions. But these two solutions are still not totally agreed by community. This problem are not solved. And for parallel NAND migration, I think the community didn't use this way because they didn't meet storage issue and the network issue as complicated as AliCloud environment. So they don't have this requirement. So maybe the community didn't use these 2 ways. So I guess that the performance, for example, the downtime and the break time are still bad. Okay. Any other question? Does Amazon use live migration at AWS? No? Do you have plan to use live migration? Okay. That server has some improvement. Angel Corp can answer your question.
What's this?
Hey, Angel. He asked a question that I just introduced our optimization and enhancement based on Zen 4.0.1. His question is that, does the new Zen solve the problem, the performance issues. Because, for example, at the old Zen, the downtime is varies from 3 seconds to nearly 20 seconds.
That's not a hypervisor.
Yeah, that's not a hypervisor. That's tool stack.
That's a tool stack.
Yeah.
So there's no change as far as I'm aware of that.
Okay.
At the moment, the predominant source of downtime is, well, certainly in Zen Server, is synchronizing access of synchronizing the write access to shared disks. That's currently the predominant factor.
Can you tell us the date you have tested? Can you tell us the time you tested? Because we use our old server, the Zen server, I forget the version. At that time we tested, the break time is about 5 seconds, and the downtime is 5 seconds, and the break time is 8 or 9 seconds.
It's definitely not that bad.
Definitely not that bad.
The performance metrics will scream at us if we've got more than 4 seconds.
More than 4 seconds.
More than 4 seconds elapsed latency on network traffic.
Okay, so currently
there are a huge number of factors that affect it, including just raw speed of access to the file system.
Okay, so your latest data is 4 seconds, right?
On properly configured hardware that isn't
Okay.
contention.
Okay.
This is a thing. As soon as you've got a shared resource that actually comes under active contention, then the downtime can balloon. That's an infrastructure problem. It's not a software problem.
And at Alibaba, we do some optimization, and we reduce it to about 200 milliseconds.
That seems quite impressive.
Yeah.
Patch is welcome.
Yeah. Okay.
Do you plan to upstream your work?
Because we use very, very old Zen version, so it's some difficult for us to we want to contribute to the open source, but you know that there's a lot of work because we use very, very old version.
Most of your work are based on 10E.
Yeah.
It's been removed from the current.
Yes. But the idea you can use it, for example, the parallel line migration, and the work around the VM domain destroy. The same idea. You can use the XL to solve these problems. XL, I think, if we use XL, the data will be much better, because you know that path is not good for performance. We can have some talk after this topic.
Okay.
Yeah, okay. And by the way, we have now have some solution for TC issue.
Yes. Do you know when that's going to be available in hardware?
Yeah, hardware.
Yes. Where?
Based on hardware. We cooperate with Intel, and they will provide some new servers to us.
Ah, fantastic.
Yeah, fantastic. This problem was not solved by Zen and Kevin right now. So the basic idea is that Intel will add some RDT, some scanning microcode to VT.
Yes.
Yeah. So
we did discuss this at the hackathon. I just want to know when that's available, because I've got a lot of customers that want that as well.
So if we solve these problems, we can contribute to the community.
Yeah. Presumably you need a microcode patch and then set something in the VMCS.
Yeah.
That would be awesome if we could get it on Intel.
Yeah.
So at the moment, AMD has had it since version 1. AMD's had it since before SVM. It was present in the base architecture in the K10, I believe, which was.
I know AMD has patent about this idea, but they don't have product.
Yes, it's all in all product.
Yeah.
AMD can already do full scaling.
They can do full scaling.
Yeah, scaling.
Okay.
TSC, that's been around since the K10. And Zen uses it. So your Zen VM doing your VM doing RDTSC on AMD is more efficient after you migrate it.
Okay. In fact, this feature is this feature is highly desired at cloud computing.
Sorry?
This feature to support TSC, this feature is highly desired at a real cloud environment.
Yeah, but there are also clouds that use AMD kit. We have a lot of customers that use AMD because it's cheaper.
Yeah. Okay. Okay. Thank you.